we're going to be building, focusing on how we can make our AI application more reliable using Galileo and MongoDB, the features that we have in MongoDB that can help tune the relevant context that we have. But also, Roy's going to give us an insight into what does AI reliability actually mean. He's also going to give us some insight into what do we mean by AI hallucination. And we'll be looking at other stuff such as hybrid search, domain-specific embedding models, and all of the buzzwords you'll be seeing today. So you're going to see a RAG pipeline, you're going to see an agentic system, and you're going to see how we can evaluate all of this type of systems with different evaluation metrics, either deterministic or model graders. On that note, Roy, I'll hand over to you to just introduce yourself.
Hi, everybody. My name is Roy Schwaber-Cohen, and I'm a principal developer advocate here at Galileo. I'm very happy to join Richard today. And yeah, hoping that this will be helpful and meaningful to people here. We're hoping to show some stuff about Galileo and kind of give you an idea of what we mean by AI reliability. And I know that Richmond has prepared a really awesome demo for you all to kind of walk through like a pretty complex example that will really showcase where both of our technologies kind of come into play.
Yes, excellent. Yeah, the use case I'm actually going to be showing is a coding agent. So for those of you who are lazy developers like myself, I'm going to tell you the story and I'll tell you why I built this specific use case, which is very exciting for me. So stay tuned for the demo aspect. But the agenda today, we're going to talk about what Galileo is. We're also going to be looking at LLM as a judge for evaluation and what you might see people refer to as model graders. Then we're going to be looking at RAG and agentic metrics whenever you're building their system and how you can help evaluate them. Then we're going to be looking at how you can use Galileo to build custom metrics and the observability lifecycle. And then I'll be talking about how MongoDB fits within the AI stack, mostly helping you to build AI and AI agents. Then we'll be going through the code for the coding agent that I built to help me stop being a lazy developer. So the code is going to be shared for this particular presentation. We're going to share the code. I'll share the branch to the code, and as usual, it's going to be in the Gen AI showcase. But I'll share it halfway through the presentation when we get to the demo. On that note, Roy, can you tell us more about Galileo?
Yeah, sure. So Galileo is an AI reliability platform, and I think the question that you may have is like, what do you even need in an AI reliability platform in the first place? And I think, and maybe we can switch to the next. I'm sorry, this is going to probably be the only one where I'm going to actually ask you to do this. I think that like the answer to that is basically it's in this bizarre paradox that we're seeing with the rise of capabilities in the LLM space, right? So we're seeing LLMs being able to do better and bigger things, being able to reason more, or at least pretend like they are reasoning. We're seeing that they're able to actually accomplish more complex tasks and actually be more useful in all sorts of ways. We're also seeing them being more precise, being able to use their context in a much more efficient way. But at the same time, the confidence that people have in LLM systems and Gen AI systems as a whole is actually going down. I mean, this is based on a lot of different research. I can point people to some Gartner research that has been done about this. A lot of people are talking about scraping AI agent projects, again, really due to the fact that they are not able to really trust them. And the reason is why? The reason is the question is why. The question is why is this confidence gap actually increasing? Even though LLMs are improving, we are trusting them less and not more. So I think that the biggest contributor to this is the fact that naturally LLM based applications are more deterministic than more non-deterministic than deterministic. And as we are moving from this deterministic software world into this non-deterministic software world, we're basically losing a lot of the tooling and mechanism that we used to have, that helped us kind of test and ensure that our software was working in the way that we intended it to. And so the question becomes, like, now that we are not in a world that is fully deterministic, what are going to be the types of tools that are going to help us understand whether or not the applications that we are building are doing what we intend them to do, or not? So I think that, like, the answer to this is essentially evaluation. That is the crux of what Galileo is about. Um, Basically, the premise is, if you cannot test an application in the same way, right, like that you used to, right, like you can't basically give it an assertion and basically determine whether it is true or false. Basically, what you want to do is evaluate your application through non-deterministic means. And what I mean by that is, and we'll talk about this through my portion of the talk, is basically we've come up with a set of ways to uh, essentially look at what the application actually does, and use the appropriate tools to evaluate whether or not it accomplishes its goal or not. So again, we're not looking for a deterministic output because we know that we're not going to get one. We're going to look for non-deterministic tools to help us assess whether or not the goal that we are trying to accomplish has been actually met. And so for that, I think that the best tool for the job has become the LLM as a judge, right? And it is not an end all be all tool, but it's definitely at a cornerstone technique that we are currently using, and we are seeing a lot of our customers having success with. And this is for 4 reasons that I can list here. So first is, the LLM goes beyond your traditional metrics. So where, in the past, people may have used metrics like blue and rouge to kind of like understand like the overlap between some ground reference to the text that they were getting from their application. Now we are going beyond that, and we're kind of relying on the ability of the LLM to understand context and meaning in a greater scope. And kind of give us a more nuanced understanding of whether or not, again, we hit the mark when we produced some result. That kind of releases us from the need to even have some kind of ground truth reference, and we're instead relying on the LLM itself to do that job. We'll see in a couple of slides, like exactly what we're doing to mitigate the fact that there might be some kind of bias in the LLM itself. But those are problems that can be solved. Now, beyond that, like, we can create particular LLM jobs that are task specific, right? So we don't need to have like this generalistic kind of methodology. Again, the more traditional metrics are very generalizable. These can be task specific. So we can look at tasks like, and we'll see this in the demo as well, right? Like when we have a RAG process, right? Like we want to determine whether or not the chunks that we retrieved are actually relevant, right? They're actually being utilized properly. Those are things that an LLM can evaluate for us. And when they are given these very specific tasks, they're actually doing a very good job at accomplishing these tasks and giving us a faithful score. Um, One of the things that can't happen in traditional metrics is that LLMs can give us an evaluation of subjective dimensions, right? So there is no one truth, right? As it comes to, even when we're talking about like business logic, right, and business kind of knowledge, right? Like what one uh, company will define as its truth, as its kind of like ground truth, could be completely different from another. Their goals could be completely different. And so we can have this evaluation be tailored to their specific subjective dimensions, right? And how they see the world. And then most importantly, what we can see is that there is a much higher correlation between LLMs as a judge to a human judge than there is traditional metrics to a human judge. right? And that is perhaps the biggest question, right? Like, how can we scale out the abilities of humans? And the answer to that, in again, at least in the evaluation space, is by leveraging LLM as a judge. I'm going to go very quickly over this chart. Basically, what we can see here is we've collected basically the performances of traditional metrics on the left, LLMs as a judge on the right, with the exception in the middle here in blue, which is BERT score, which actually looks at a semantic score, a semantic correlation between ground truth and the produced content. Which has like you see like the correlation between the metric and the human is very high. Again, the price of that is that you need the ground truth, which has to be produced by someone. You can't just like get it for free. And so it still remains that the best way to go about evaluating a lot of content without having to produce ground truth is going to be LLM as a judge. So here, I just wanted to walk very quickly through the process which we use for LLM as a judge. So we've developed this in-house called it's an algorithm called chain poll, and it basically means something very simple, right? We take the completion that the LLM is produced, and then we run that through a chain of thought prompt that is ensembled, right? So we have not one LLM producing that chain of thought result, but rather n LLMs. This could be like 1, 3, 5, 7, obviously an odd number so that we don't have to worry about ties. And so once and we can use any model for the process of this LLM generation. So like what we tell a lot of our customers to do is if you use, for example, like the GPT family in your application, you probably don't want to use the GPT family in your evaluation, right? So like you keep that bias away from your evaluators. And basically what these evaluators produce is a score between 1 to 0 that gives us like for that particular metric and an explanation of why that score was produced, right? Which is again another part of really understanding what exactly happened and why. So as far as the metrics that we provide out of the box, um, like I'm not gonna go through all of these, but I just wanted to list them out here. You can peruse them and you can go to our website to basically read more about them. But they fall into 4 general areas. Um, Ones that have to do with agentic performance, ones that have to do with sort of like just general model confidence to like say like, hey, this model is producing results that have low confidence in them. So we look at log props, etc to kind of indicate those kind of metrics. Then we have response quality metrics, which mostly have to do with both RAG, but not just RAG. We're looking at any response that the LLM produced, and we can say, hey, is it correct? Is it complete? Right? Again, based on open domain kind of metrics there, but that's still incredibly helpful, right? To know that if you've built a system, it's not going to start telling you that the moon is made of bananas, right? That's something you don't want to happen. And then finally, something that a lot of our customers find incredibly important, which is safety and compliance metrics. And those include PII, prompt injection, toxicity, etc. Those are the things that you might expect. What I would want to say here, though, is that that is not the end of the story. It's actually only the beginning of the story. No, Heather, the moon is not made of bananas. I'm sorry. To bust your yeah. Anyway, uh, the out of the box metrics are only the beginning of the story here. What we see a lot of our customers doing is create their own custom metrics, right? And that's where really the strength of our platform comes into play, right? You could basically define your own LLM as a judge or code based, and I'll touch on that a little bit better, but I just wanted to plant that flag here. Today we're going to see like mostly like the use case that we're going to see is about RAG and agentic behaviors. And so I wanted to just like give you guys like an idea of what those metrics look like a little bit and touch on them a little bit more. So we can ask, for example, in the RAG world, right? Like we can ask questions like, is the model's output sticking to the given context? That's called context adherence, right? Sometimes, right, like you give the model context and it's still, again, quote unquote, hallucinates, right, content that's outside of that, outside of the context that it was provided, right? And that could be due to bad prompt. That could be because the relevance of the context to the question was low, right? So like there could be a lot of different causes to this failure mode, right? But this is like an indication for you as a developer to know where to start looking, right? Then we have things like completeness, which answers the question, is the model's output fully answering the question, right? So sometimes, again, we give an answer to a question, but it doesn't actually cover everything that was asked, right? And the goal of this metric is to answer exactly that. Chunk attribution and chunk utilization are essentially very tightly connected, right? So they're basically telling us whether or not a chunk that we've retrieved has actually been used in the final answer. And that again gives us a better idea of whether or not our retriever is working as we intended it to, or maybe it's doing some overfetching or underfetching or whatnot, right? Now, it's really important to note, and you'll see that later on, having low or high chunk utilization, chunk attribution doesn't always mean that something is right or wrong, right? It kind of gives you an idea of what is happening, right? Sometimes you mean to have low chunk attribution. So for example, you mean to overfetch so that you can do better re-ranking, right? Sometimes and sometimes you don't, right? Like sometimes you want your chunk utilization to be high. Sometimes you want your chunk utilization to be low. It really depends on your particular use case. So for agentic evaluation, there are essentially different spaces where we kind of come into action. And the main ones, right? Like I think the most important ones to mention are action completion, tool selection quality, and tool errors. Right. So everybody here, I'm assuming, already knows how an agent works in general, right? Like we have some LLM planning what the agent is going to be doing. Then there's going to be a step where the agent is going to be given the ability to choose a tool from a selection of tools. Then it's going to execute those tools. It's going to repeat, right, the tool execution until the goal, right, that it's trying to accomplish has been accomplished, and then it's going to say, "Hey, I'm done," right? And for these three, right, like we have metrics that correspond, right? So for tool selection, we're going to be able to tell you whether or not, given the exact context, right, that the agent is on right now, is the tool that it has selected, right, the best tool for the job, right? Then when the tool was actually executed, did it error out or not? And this is not always trivial to tell, right? And this is not always an actual error, right? Like it could just be a really weird kind of text that came back, right? That indicates an error. And then finally, action completion, which is whether or not the goal that the user set out to do, was it completed, yes or not? I'm gonna zoom through the next kind of slides because I feel like I'm overrunning on my time. So as I mentioned before, we have the ability to do custom metrics. The main point that I would like people to take from here is basically that when there is business knowledge or expert knowledge that needs to be imbued in the process, right? You do that through custom metrics. By allowing subject matter experts to basically define what the metrics are for the application are going to be, right? Like we're allowing them to basically shape the way that the application is developing, and the way that basically the definition of good and what it looks like is going to be. And yeah, there are two two basic ways of defining custom metrics in Galileo. Like I said, one is going to be LLM as a judge. The other is going to be custom code. I'm not going to go into that in great detail right now. One other thing that's important to note that Galileo is really good at is basically taking human feedback and improving the metrics as you go along. So we know that either the custom metrics that you create or the metrics that exist already out of the box, again, they have different meanings, they have different nuances for every application, for every company. And we allow you using a basically built-in process to introduce human feedback into the equation and to improve these metrics over time. I think we can just go over, just skip this one. Yeah, this is my last slide. The basic premise is here, like we see this process as kind of being obviously part of the SDLC in general, right? Like you, in the same way that you would run your tests after you create your software here, right? Like we go through this cycle of creating some prompts, debugging those prompts, running CI/CD tests that are again patched into evaluations. You look at the metrics that those are that those create that those generate, right? You curate your tests. You basically improve those metrics over time, and then you repeat, right? You create more evaluations. You create more. You run more experiments, and you rinse and repeat to basically improve this process over time. That's it. Thank you.
Thanks a lot. Thanks a lot for that, Roy. So we got a lot of questions that's come in, and I see folks asking questions in the chat. Could you please use the Q&A box so we can address them live and also have it recorded? So I'm going to ask some questions that are coming in from the audience. I see one that just comes in and says, can I choose the various model in chain pool, or based on the LLM integrated Galileo picks up any random model accessible?
No,
Also,
so
sorry, go on.
let me just answer that one. So basically, you can integrate with basically Galileo supports all models, or I think almost all available models. And you could, once you have your keys, you can basically set them up in Galileo, and then you can run your chain pool with that model. But every judge has to be one particular model.
One thing I learned from your talk, Roy, is actually I was listening attentively. So many good information is to reduce the bias in your evaluation framework. You should not be using the same LLM you're using to generate. You should not be using the same one to evaluate. I don't think I've ever heard that before, but so that was new to me, or maybe I'm not going to enough webinars like yours. But that was very, very interesting insight for me.
Yeah, I mean, we could just like think of it about it logically. I mean, again, this is not to say that like if you don't do that, like there's going to be repercussions and you're definitely going to get, false positives there. But I think that like just logically speaking, and this is something that I do myself like all the time, when I, create content or do anything, what I mean? I take my creation, I ask another model to critique what the first model did, right? Because like if you ask your own, if say like you're talking about code generation, right? Like if you create code, right, with your whatever IDE, and you use, I don't know, whatever model, right? And you ask it, make this code better, make this code better, make this code. You keep doing that over and over and over again. At some point, it's going to say like, hey, like this looks to me like optimized code. That's great. You know what I mean? Like I don't need to make it better, right? But if you take that optimized code and then throw it on another model, not from the same family, right? Like even a more advanced code from the same family, right? Then you start getting more optimizations, right? And that's exactly where this is coming from. It's basically saying like, I don't want to assume, right, that like the model that's going to produced it is going to say, yeah, like, the thing that I produced is great, right? I'm just going to take it completely to a differently trained model, right? And avoid all of the bias.
Thanks for that explanation. So we've got some more questions. One very quick one. Is Galileo open source?
No, Galileo is not open source, but it is free to use. So we are a commercial company. We have enterprise customers. That's our main thrust. But we do have a free version that you can start using right now. Just go to galileo.ai.
Excellent. And another quick question: can you bring your own LLM models?
I believe we don't support that quite yet, but it is on the roadmap. I think that right now we support out-of-the-box models. Um, it is possible that if you're OpenAI compliant, in some scenarios we'll be able to support that, but that's something that we would have to customize. It's not, as far as I know, it's not available in our free version.
Excellent. So I'm going to go into MongoDB within AI and AI agents to see some folks asking questions around how can we use MongoDB in AI? Well, I'll set some common ground between everyone here today so we can then build upon definitions, and then we're going to go into the code. I'm going to blast through my slide because I'm very excited to show you what we've built today to help showcase improving the reliability and trust of the AI systems you're building with Galileo and MongoDB. So we started off with LLMs, right? LLMs are simple chatbots that have language models behind them, and we're able to have fun with them to ask different questions. Then we went into RAG chatbots where we're able to give them more specific domain data, and then we're able to get more relevant, personalized outputs. But with the emergent, then with the scaling of the compute, the data, and the number of parameters in these language models, what we actually start to see is emergent abilities in our AI agents and agentic systems, such as tool use, advanced reasoning, and all of this has brought us into the era of AI agents. So we're going to be saying AI agents a lot. And when we talk about AI agents over here, we're talking about computational entities that have access to the environment through perception through input, can actually take action through tool use, and have some cognitive abilities that is steered by an LLM. But more importantly, they have a form of augmented memory. So that is where MongoDB comes into the world of AI agents, giving AI agents a form of long-term and short-term memory. We'll be looking at that today. So this is the lay of the land of what an AI agent is, and where this is what we mean by when we talk about memory. We talk about long-term and short-term, and there are different forms of memory. But MongoDB operates in your RAG pipeline as that operational and vector database. So you have your metadata and your embedding sitting side by side in one single database. Just to show that we also have Voyage AI as well. We're going to be talking about Voyage AI extensively. When we get into the code section, I'll tell you why we are. But this is what a typical RAG pipeline looks like, where we have an embedding model, operational and vector database, and a re-ranking process, all to optimize what we're getting to the LLM. So all of this is centralized around RAG, and RAG is a common term that we all know and love and use in our AI applications today. So when we talk about RAG, we're talking about information retrieval, right? So today we're going to see text-based information retrieval, where we have a query, and we can use the search operator in MongoDB to actually look for any matching query within our documents and return the matching documents to the application layer. We're also going to be looking at vector search, right? This is when you have a phrase that you can then pass into an embedding model, and then you generate a numerical representation of that data object. And now you can start to conduct some form of vector search operation within your database. And now you then return documents that have semantically similar content to your input. And now you can start building RAG, semantic search, or recommendation engines. But you can combine both. We're going to be seeing that today. We're going to be seeing hybrid search, where you're able to retrieve by keyword, retrieve by similarity, and have this form of hybrid result. And this is another way that MongoDB helps you build trust in your AI system, right? By using different retrieval method to get the context that you want, to get the documents that you want, because vector search is not all you need in AI. You need more robust retrieval mechanisms. And one thing that we hear in the field today is people talking about AI hallucination. And as Roy mentioned, when people use that term, what they really mean is, how can I trust the system that I'm using, the AI system that you're building? How can you consumer trust it? And we're going to be showing you different ways to do that and improve trust, in essence, improve AI reliability, and at a very high level, reduce what we call AI hallucination as a field. So MongoDB actually operates in different parts of your RAG pipeline. We use Voyage AI to provide you embedding models, which you're going to be seeing today. And we also use Voyage AI to provide you some re-ranking models as well, which you're also going to see today. More specifically, Voyage AI provides domain-specific models such as code, legal, and finance. And these are fine-tuned embedded models that are optimized for specific domain as specified. But there are also general purpose embedded models, such as the text one, which is very performant. And we have the multimodal embedded model that can take different inputs. So you can have text and images as input into the same embedded model. So for use cases where you're ingesting PDF that have tables and images and text, you would be looking to use Voyage AI, state-of-the-art multimodal embedded models. And we're also going to be seeing re-rankers. So this is really an AI application where we're using LLMs for generation. We're using embedded models for chunking, for taking our data and creating embeddings. We're using re-ranking model for actually re-ranking retrieved results. And when we're using, we're also going to be using a bunch of models as well and systems that can actually help us build more AI reliable system. Today, we're going to be looking at Voyage Code 3. Remember, I'm a lazy coder and I'm trying to build a coding agent that can actually write me unit test. So I'm going to skip through this very quickly. This is just the fact that, so this is just a slide that I give to developers that whenever anyone asks you or your manager or your CEO asks you, what is an AI agent? You just tell them, Richmond said the agenticity of a software is a spectrum, right? There are different levels to this. So I can't give you one definition, but you can look at it as self-driving cars where there are levels to the agenticity of a software, and these are the levels. So overall, in MongoDB, we're focused on making sure that we're building a system that developers can rely on to build their AI application. And we're doing this in conjunction with making sure that you have a system that has that high enterprise grade security, that is production ready, and you can use anywhere. So this is what we're doing at MongoDB. This is our promise, and this is why we work very closely with folks like Galileo to learn and bring the best of the field to our developers. So before, it used to look like you would have different vendor solution for all of these components in your AI stack. While you're using MongoDB, what you're going to have is your embedding model and all your search process and your re-ranking model in one platform. So you reduce tech stack sprawl. You reduce the amount of knowledge you have to hold in your head about different documentation from different systems and solutions. We make that very simple, and we bring that all into MongoDB. So I want to go into the code, but the last thing I'm going to say is the aim of this webinar is to show you how to make your AI systems more reliable. And Galileo helps you to do that by creating custom metrics or custom evaluation metrics. We also have their own metrics as well that evaluate different parts of a RAG pipeline and an agentic system, which we're going to see today. In MongoDB, we focus on improving that retrieval process, improving that trust by giving you domain-specific embeddings, by making you implement different search mechanisms and adding the capabilities for re-rankers model through Voyage AI. The point is, we're aiming to reduce AI hallucination and increase reliability and trust. On that note, I'm going to go into the code. I'm going to set some context for the code here before I start. Roy, while I'm switching, could you see if there are any questions that perhaps maybe we could answer?
Yeah, I'm going through the questions and I'm answering them as we go. So don't worry about that. I'm on that.
Excellent. All right. So can I get a thumbs up if we can see my screen?
I can see it.
Excellent. All right. So this part is broken, obviously, but this is the use case of this. The use case of this is actually a coding agent. So I'm going to close this and I'll get to that later. So the use case of this is a coding agent. So I have a GitHub repository. It's open source, but it contains no test. Well, minimal unit tests. I know that's bad. The coding gods are definitely angry with me now. But one thing I'm doing is I'm trying to build a coding agent. Obviously, I could use Cursor, but what fun is that, right? I'm a developer. Let me build it from scratch. So I'm building a coding agent that can go into my repo, access all of the files, and actually create some unit tests for me. And I want it to be agentic, which means I want to give it tools. I want it to be like a chat interface, and I want to talk to it. I'm basically making cursor at this point. But today, this notebook, which I'll be sharing to you once we get halfway through it, I'm going to be sharing with you a branch that gives you this notebook, which would then go into the main branch of the Gen AI Showcase. And those of you that are regular in our webinars know what the Gen AI Showcase is. So this notebook basically.
Hey, Richmond, just before you go on, I think there have been a bunch of questions that are kind of like going around the same theme, which is, can MongoDB be used as a vector DB, and also can you be used as a complete memory system?
Yeah, the answer is yes. MongoDB can be used as your vector database, and we're going to be seeing that now in this demo. And can it be used as your memory system? The answer is yes. You could, if you're a very exploratory and adventurous engineer, you could build your own memory management solution on MongoDB. But if you're in the world of integrations, we have integrations with Mem0, with LangChain and LangGraph that allows you to store the state of your agentic system and use other features like semantic cache and long-term memory. So Llama Index as well is one of the integration folks we have. So if you're an adventurous developer, you can go both ways. But the key thing is you can store your vector embeddings and your metadata in one database. So very quickly, I'm going to go through the major parts of this notebook. So part one focuses on the data ingestion process. This is important because I want to show you the specific embedding model we're using. Part two talks about the information retrieval and the RAG process. And part three, we're going to see the coding agent. After we're done executing the code, and of course, we're going to be doing it live. I like to do live coding, and you guys can watch me maybe debug some bugs. We're then going to go into Galileo and see some of the metrics that Roy was talking about. So very quickly, we're going to start with the ingestion process. I'm just going to scroll this up if I can do that. Clearly, it's not going to let me. Let's do this. Excellent. This is just going to help me navigate through the notebook very quickly. It's quite extensive. I cover a lot of ground here. So this is a coding agent use case, and I'm using the repository. It's called Memories. It's my personal repository. It has over 57 files, and I'm using a library called Git ingest to get a full markdown of this repository and ingest it into MongoDB. More particularly, when we're generating our embeddings, I am using Voyage AI. And the embedding I'm using is Voyage Code Free. And I'm going to show you why I'm using Voyage Code Free. And rather than tell you, I'm going to do a comparison with another embedding that we all probably use and know is Text Embedding Free Large. Now, this is one of the best models you get from OpenAI. So this is from OpenAI with 372 dimensions, and the Voyage Code Free is a domain-specific model for coding use cases, and that has a dimension of 2048. So you can see it makes sense for a coding use case, like building a coding agent. I want to be using Voyage Code Free. That's one reason I'm selecting Voyage Code Free over here. So this is the embedding generation process. And what it looks like is we're going to create an embedding we're going to ingest some data on the entire repository, on the metadata of the repository itself, with some embeddings that we generate over here. As you can see, we generate some OpenAI embeddings and some Voyage AI embeddings. We then generate embeddings for every single content within the file of the repository, and we store that in MongoDB. We're going to see what that looks like in the database. So very quickly, I told you we're going to be doing different search. In the first step, when you get this, there's loads of graph. I've tried to make this as very simple as, there's loads of images. I've tried to make this as very simple as possible, and where you can get all the information as to how things are essentially running. So we're going to be looking at semantic search, and semantic search powered by vector search. And Roy, can you please go into the first step of what this line is?
Yeah, for sure. So basically, as you see, we're importing log, the method log from Galileo, and this is basically a decorator that helps Galileo kind of look at specific functions within your application. And here we're specifying to the log function, to the log decorator, that the type of function, or what is called here in our parlance a span, which is basically a part of a trace, which you'll see later, is a retriever span. That basically means that we expect there to be a set of documents that are going to come back from this function, and we're going to apply all the metrics that have to do with retrieval to this particular span. And then the name parameter is basically the name of the span, and you'll be able to see that in Galileo once we've done collecting all the logs.
Thanks a lot for that explanation. So I created a function called semantic search, and within this function, very simply, I'm taking in the user query, creating a vector of it, an embedding of it, and I'm using that embedding to actually use to search through the embeddings in my collection, which is going to be all of the files of my repository. So whenever I send a query like get me a certain class, it's through vector search is going to get me all the files that are semantically similar to that specific query. So that is why I'm using vector search here. And it's very easy to use vector search or implement vector search systems with MongoDB. Here we have the vector search operator. You pass in the index, which the notebook specifies, and when you get it, you can go through it. And you pass in your query vector. This is the query embedded. This is the user query that has been embedded. And now we can look at we can specify the path of the location of the embeddings within our documents and the number of candidates and the number of results we want to return. And now we have a project stage, which just removes a bunch of attributes that we don't need. And now we then look into creating a pipeline that has a vector search stage and a projection stage, and we run that through the aggregation framework, and then we get our results. And I'm going to run this live. So I'm going to run this cell. Then the user query is very simple. This is the user query is saying, get me the class responsible for creating agents and running them, and it has all the codes for calling LLMs and tools. Now, the name of this class, this is my repository. I know this class is called, the file that we're looking for is called the memagent.py. So the repository I built is a very experimental agentic system and a memory management system that I have, but I know the exact file of the system. So this is a user query. We're going to use vector search using OpenAI embeddings, right? And we can see what results it gives us. Very quickly, it gives us a bunch of results. This is bad visualization, but we're going to do the same thing with Voyage AI embeddings, because remember, not only can we store embeddings in MongoDB, you can store multiple embeddings. So within the actual metadata, I have 2 embeddings that I could do searches on. So I print the results, but now this is just a boiler code to view the results, and we can compare the results right over here. So this is the results, right? So we see the file name from OpenAI, and we see the description, and we can see the score. But here we see the file name from Voyage, the description, and the score. And you can start to notice, right? The first step of evaluation is vibes, right? You're just going to visualize stuff, right? You're getting a feel for it. Now, I know what file, I know what the answer is for that query that I asked. And I said the answer was memagent.py. But we can see that for OpenAI, you have the real answer ranked number 2, or the second results. But for a code domain specific embedded model, you have memagent as number 1. The right answer is number 1. But not only that, you guys can probably notice the score, right? We have 0.74, 0.73, but the score seems a bit higher for Voyage AI, which is the score is higher because we have more of a domain specific embedding. So in OpenAI, this is a general purpose embedding. It probably has a bunch of other data within this model, but for Voyage Code 3, it's specified. It specializes in understanding the semantics of code or code-like inputs. Hence why we have a higher score. The question is, why does the score matters? For those of you building RAG and agentic systems, right, you would know you can't just take all of the search results you get. You have to actually put a threshold. Sometimes I say my threshold is 70%. So anything less than 0.70 or 70% relevance, I'm going to throw away. Or sometimes you might say anything less than 80%, I'm going to throw away because there is not that high relevance. So if you were to take that heuristic, you would see that if you were to have a 70%, you're only going to be taking the top 2 of the OpenAI embedding. But if you had one of 70%, you're going to be taking all of the Voyage AI. But even more so, if you had a high threshold of 80%, you'd be throwing all of the OpenAI embeddings results away, and you would still have at least the top 4 of the Voyage AI one. That's why domain-specific embeddings matter and are relevant. So this is another way you can build that AI, improve AI reliability and trust. Okay, so we've run that. So we're going to run the hybrid search. I'm going to go through the rest of this a bit quickly. We'll run the hybrid search because MongoDB is not just a operational database. It's also that single database for your operational data and more. Now we have hybrid search, and you might be able to notice that the results are actually quite different now. MemAgent is still number 2, and here we see MemAgent is still number 1, but we're using different search mechanism, and the results that are returned are different. I think if we let's see if we run this again. Yeah, the results are different than what we did with vector search, and that shows that you can get different results with different retrieval techniques. Now, which one works best? That's for your evaluation to decide. The first step of this, I show like a deterministic approach, which is using some of the traditional evaluations we have, such as precision and recall. I actually generated a data set to use as my ground truth data set. I say I generated it. I used an LLM to generate it. This is what it looks like. We have input, expected output, and expected files. Is where we have a query, and we get a number of files that we expect the query to meet. So, and we use this as our ground truth data set. Again, this is generated by LLM. It's not been evaluated, it's not been inspected by me to make sure it's correct. But this is a very quick way to show how you can use traditional deterministic approach to evaluation. I'm going to go through this very quickly just to show the importance of relevance. So we measure the precision and recall, but I'm just going to scroll and go through things very quickly to go into re-ranking for the sake of time. Remember, you're going to get access to this notebook in a second when we switch over to Galileo. So very quickly, here we can see we have the re-ranking process. Remember, re-ranking is when you have your return results, but from the return results, you do a reordering, and with the reordering and the user query. The reason why you're doing this is because you want to improve the ranking of the results in a less resource constrained space. What I mean by that is when you conduct vector search, you're using an algorithm called approximate nearest neighbor, which actually gives up a bit of accuracy for efficiency. But when you actually get to another step of your tier 2 retrieval process with a re-ranker, you can then reorder. So one thing I show is how you can do this with Voyage AI re-rank. But if I'm scrolling very quickly, I show you in OpenAI, this is Voyage AI's re-ranking position. So this is OpenAI re-ranking. So we take the initial summary results and then we re-rank it. We can see that from re-ranking, we change about 3 documents. We change the position of 3 of the retrieved documents. We move 3 of them up, we move 2 down, and there are changes to every single document, right? But with Voyage AI, we actually only have to move 1. We just move 1 up, 1 down, which shows that just using that domain-specific embedding is actually useful and might even help you out of the box start to get some good performance. So one thing I'm going to do is quickly rerun this process again so we can look at the metrics that we care about in Galileo. So I'm just going to scroll up. Do bear with me, but do ask questions as well.
I think that there were a couple of questions that might not be fully about this particular topic, but are tangential for sure. I think 3 of them I would say. One is there a MongoDB store integration with N8N for RAG use cases?
Yes, the answer is yes. We have that we use MongoDB as memory for your N8N pipelines. I'll make a note to look for the documentation for that.
Okay. So sort of in the same vein, does this Voyage AI do anything to help non-techies like me use MongoDB? I'm currently using it to help I'm currently using it with the help of Cursor, but I often hit the limits of what I can do.
Okay, yes, it can. And by non-techies, if you use a tool like N8N, it has this visual workflow, right? So you can build your,
Right.
right? And it makes it easy over there as well. And Voyage AI, we do have Voyage. You can actually implement some code using N8N as well, where you can bring in your Voyage AI embeddings as well.
Sweet. And then maybe the last one for now is I wanted to use MongoDB as a long-term memory store for my AI agent and LangGraph. I want to store things like chat history, metadata, results, summary, etc. What is the best way to store it, and how does the agent retrieve it from MongoDB?
That's a good question. I will answer that because we're about to flush all of the metrics into Galileo. And because of time, I want Roy to tell us more about the Galileo platform. So I'm just going to share my screen over here. Do you bear with me 1 second? And we can see the Galileo platform.
Kidok.
I'm just going
So
to.
actually, if you can go back a little bit, maybe to that project page, just I could just like give people like a little bit of an orientation. Um, so basically, Galileo is comprised of projects, which is what you see here. When you go into your Galileo project at first, you'll see these API key instructions. And then within each project, you can have one or many log streams. A log stream corresponds to potentially an environment. Basically, it gives you a way to containerize or encapsulate a set of traces. And now if you click on View All Logs, here what we have are a set of sessions, right? Where a session is basically if we have one, if you can imagine, like I'm talking to a chatbot, right? Like right now we saw um, a Python notebook, right? But in the real world, quote unquote, you'll see an actual chatbot, and imagine you connect to that and you start talking to it. As long as you don't refresh, right? Like you are still in the same session, and so you may have like multiple interactions with that same chatbot. That chatbot may be triggering an agent that may do multiple things, and all of those will go into the context of one session. In this context, because we're using an IPython notebook, and we are flushing, right? What you'll see is within the session, I believe you'll have basically a single trace. So let's click on that session. Oh no, so we have multiple. I was wrong. You can see multiple sessions for no, so you have 9 sessions, but one trace in the session. I was correct. Okay, great. So basically what you can see here are all of the steps that were logged by our logger, right? And right now, I think we've in this particular session, what we're seeing is that we are only tracking the retrieval steps, right? And so when if you can click on any one of these, right, we can see what happens on the right side, right? We get the name of that retriever, right? We get the actual JSON input to that retriever, right? And then the output, so we have 10 chunks retrieved and whatever number of total tokens. And Richmond, I don't know, do you have metrics enabled on this particular? There we go. So in this particular session, we can see, right, that like the actual attributed tokens to this retriever were 1 out of 10. That means that only one was actually used in the final result, right? And if you go down below, utilization is also kind of the same. It kind of matches up, right, in the sense that only 3% of the retrieved chunks were actually utilized. Maybe that's a good thing, like I said, right? Maybe that's a bad thing, right? It's up to Richmond to now decide whether or not this kind of gives them an indication of whether it's correct or incorrect. But what we can see is that basically we can look through how the data flowed from one element, one retriever element here to the next, and see like what were the inputs to it, what were the outputs to it, and what eventually happened. We have also things like latency and other parameters that are helpful, right, in kind of understanding what's going on here.
For the sake of time, I actually want to give folks where the code is, and then we'll go back to the explanation of this. So I could just show folks, because we are
almost out of time.
Yes, almost. And this is good because you guys can see the navigation of the Gen AI showcase, and the notebook is going to be here, right? You're going to have the notebook here, and I've just pasted it in the chat. Excellent. And now you all have this notebook where you can follow and you can run this notebook yourself. Going back to Galileo now.
Yeah, I think that kind of covers it. I mean, you can see, again, things like latency. If you click on latency up top on the left, your other left.
Oh, yeah,
there you go. You can see basically all of the events that happened, right, within this particular trace, when they happened and how long they took, right? And again, in more complex cases where we also have track agentic behaviors, this is helpful to kind of understand what is eating most of your time, what is the sequencing to basically help you understand whether or not the sequencing is correct or incorrect. And then if you click on the next tab, messages, you can see a better kind of like flow. Kind of this is a familiar trace that if anyone here used Langsmith or any of these other tools will be familiar with, right? Basically, it tells us like what happened step by step within that session. And there are a lot of other things going on here. Again, like you can, if you click on configure metrics, you can see all of the different metrics that you can enable or disable on this project. And yeah, I mean, of course, you can create your own metrics. There's a whole bunch of things that you can discover here. But for people who are interested, I recommend going to Galileo.ai, just playing around. You have good docs that can help you get oriented. And we're always on LinkedIn and X and other places if you want to reach out directly.
One thing I wanted to mention is actually this, is I love the view of this, for me anyway, personally, I love the view of how the process is taken. We can see the semantic search that we did with OpenAI, then we can see the one we did with Voyage, then we can see the hybrid search, right? Because we run everything twice. And then we see the actual generation from the LLM as well, and the metrics that we care about that I spoke about. I like it, the latency, the price, and it just shows the flow, so you can just really get the observability, the monitoring, and really know where you need to improve your systems, or down to the actual code, like the actual function.
Cool. I think we're at the top of the hour, so thank you so much for doing this and having me over.
Thanks a lot, guys. Thanks a lot for joining us, and the webinar is going to be shared with you guys in a week. You guys have the code to the Gen AI showcase, and please fill out the poll while we still have you here. Roy, thanks for joining us. Please fill out the poll. This will help us to show up better and actually make sure that the next webinar that we bring to you is excellent. So fill out the poll and help us make sure the next webinar is the best one yet.
Thanks so much.
Thanks.